Welcome! It's part 12 or something. I totally lost track at this point. But hey, it's Friday, so we have a new stream and we have some work. Primarily what we need to do is basically just clean up everything that we did like on last week's stream. So we basically got it working in terms of like everything was moving, but we kind of have an absolute mess going on here. And yeah, let's clean this up. So basically what I did between streams was not a lot. The only thing I did was I cut this deck panel from some acrylic glass I still had laying around. And it's horrible. It's like not straight at all. It's like super crooked. I just used a jigsaw and cut it by hand. So really not great. But yeah, for the prototyping phase now, it totally does what we needed to do. So basically there's a small thing we need to do. When we printed this, oh, you don't see it, sorry. When we printed these bottom corner pieces here. Hi there, the parts were like a little bit faulty, where basically the hole wasn't deep enough. Hi there, Neo. Hi there, Paul. Paul, I always schedule the streams around 3 p.m. Like that was not special. So yeah, so basically like these parts here, like they were a little bit faulty. So now basically there's plastic in the thread, and I want to try to clean this out a bit, but I don't have my soldering iron. Okay, so I guess we just ignored it for now. Let's just mount that, and then my idea is basically to just use tape for now, and tape the main board either just here on top, in the middle. That might be the easiest, to be honest, like now for prototyping, because like reachable. I don't think there's anything in the way. And the other thing is, but I did not order yet the connector. So we still have this power supply situation going on with this short cable. And I did not order yet like the proper like the plug. I don't know how they're called. Like these. I didn't order the socket yet. Totally forgot about that. But then later the idea is basically to have the power supply just like basically here. Just in the middle, we just tape it with VHB tape. And then this like deck panel basically just allows us to like mount stuff to the printer. Oops, yeah. No, but like it's always like a schedule around like 2-3 p.m. Depending like when I think about it. But yeah, that's usually when I put it up. Yeah, so yeah, that's just like why this was very important for me, because then we can kind of like get rid of the mess a bit. We can use some zip ties and kind of clean everything up. So the only thing that we don't do yet is like glue the power supply. I would just like leave it outside for now, and then I promise I will order the matching, not plug, like the socket for this, and then we can have the socket kind of dangling in the back, because we don't yet have a printed part for that to mount. It's actually like a bit of a problem still, and I didn't find a solution yet, so maybe if somebody has a good idea, let me know. But the problem is that the spacing here is too narrow basically to house the plug. So I'm not quite sure how to connect that. So we need to find some solution. Like one thing I was thinking of was like having I don't want to have the fancy one with the switch where you can turn the printer on and off. I just want to have this like very compact small one, and maybe mount it behind that, like basically you have to plug through and then like have the socket here. One option I was thinking about, need to see. The other option was, so later on, that's also why I didn't like worry about it too much yet. We will have like this like backpack here basically for all the electronics. And then my other thinking was like to plug from the bottom and have the socket like facing downward. A couple of options, not super high on my priority list. So for now we will basically just have like a cable dangling out, and then like with the socket on the back, I will make sure to like print like a little case around it. It's like isolated and no idiot can touch it accidentally and kill themselves. But yeah, that's kind of like the setup for now. And I think like I really like the idea of just like gluing the main board on top, because then yeah, it's just accessible. So if you want to change plugs and everything, I don't have to like flip the printer over. Yeah, so let's clean up this mess. And then the other thing I want to do is I want to fully assemble the toolhead today. Unfortunately, I did not receive yet the replacement for, no clue where it is, but the big white gear for the extruder. I didn't receive the replacement part yet. It's most likely tomorrow. Ordered last Saturday, but then, yeah, 5-day delivery, so it's like always Saturday, which is a bit annoying. So yeah, we can't fully assemble the tool yet, but basically I want to have all the electronics, all the cables, the software setup all done. That basically, and also I want to mount the bed in using this preliminary mounting system we have. I just want to get the bed in so that we next week can basically install the extruder gear and then technically start printing a little bit. I just want to see the machine working. Because then we can determine like what needs to be changed, and I assume it's quite a bit. So I rather want to fail quickly and see what we need to improve before like like perfecting the electronics mounting or something, and then yeah, seeing that the printer doesn't work at all. Also like the bed, we definitely will like change it, that this will not need these extra pieces, but we directly mount it to the corners basically. But yeah, that's then for like a later iteration basically. Yeah, lots of talking. I would say let's just get this installed as good as we can. Let me see if I get a little bit more. Yeah, it's also like a little bit like the max range of the camera. I still have to invest in a longer camera arm. But also like there's not a lot of space to the light. Like there's like this much space between the top of the camera and the light. So need to see. I'll need to find a solution, because if we at some point work on bigger printers, this is definitely not going to work. Cool. Yeah, let me see. So basically we have this plastic situation going on here. Let me see if I just kind of get it a little bit out, but I doubt. I could try to like put a hot screw in. There's actually quite a lot of like plastic in there. I don't think this will be. I don't think this will work. Okay, then let's just ignore this one and just mangle this in here. But yeah, this is like also more or less shape I later want to have for the deck panel. Just like nicer and black. Like the part in Fusion has some chamfers here and there, where like at the moment have like these sharp cuts basically, and it should be like nicer. But yeah, for prototyping, totally fine. Hi there, Steve. Do you plan on integrating LD into the printer, or maybe separately? Yes, definitely. That is on my to-do list. So I do have, I mean, it depends. Do you want LEDs for illumination of the print, or do you want LEDs for fancy looks? For the print illumination, I don't have anything planned specifically yet. For the fancy looks, I have a little bit of an idea, but I don't want to spoil it yet. But I think I showed it already. It kind of goes in here, the screw. Yeah, it's definitely good enough for now. I kind of showed it already. Ah, this one actually goes in. Okay, this one is tight. This one actually too. Let me see if we can. Yeah, it's like actually the screws are quite short, so I think even though there's plastic in the threads, like the top couple iterations are okay. Okay, cool. Yeah, and later there's basically now a gap between the rod here and the panel. And the side skirts, my plan is to just clip on the side skirts, basically because we have these two rods here. My idea is to just clip it on, and they will basically fill the space between the deck panel and the rod. And then basically like the deck panel rests on the skirt. Let me quickly show you kind of what I have planned. Oh, I didn't open it yet. Hope it doesn't die. Yeah, so basically at some point I designed the front skirt. And that's kind of like what I want to have for the front skirt. So the turquoise part is basically a mesh, so that like airflow is possible. And then the white part is actually a LED band, but not the LED band with the single LEDs, but like a continuous, like the SMD LEDs. I don't have it here. But basically it's like, it doesn't have any PCB visible. It's just like a continuous LED. And that basically is, there are some gaps here. So I have to like actually print it. So you see basically there's like an opening here. And then my idea is basically to loop the LED band through. And then here basically just have like a turn. So that basically on the front of the machine you don't see anything from the turn, so you just have these like bars of LED. That's kind of my idea. I don't know if it turns out like this. But yeah, the downside is they do not come as RGB, or at least I didn't find them. All the RGB ones had a PCB around it, because as soon as you have RGB you need the controllers. Maybe I find something, but so far I have like daylight white. And I think white is actually really nice to illuminate that. Editinga. Check your disco later, found a small socket for the kettle lead that might fit. Thank you. I think I have the smallest one already. I can quickly see. Yeah, that's the one I have in mind, Steve. That's exactly the one I have in mind, and it's ever so slightly too big. That's a bit of a problem. I did not consider, like, when designing the bottom part. So, oh wait, here. These. So yeah, that's ever so slightly too big. But that's exactly what I will order now. Yeah, but doesn't quite fit. So I think what I can do is like, yeah, the problem is if I want to make this spacing bigger here, I have to make the entire like bottom section bigger, because they're like more or less as high and low as I get them. Yeah, I don't know. It's I kind of like pass this issue down for later, and then maybe we have success at some point. Cool. Yeah, so we kind of installed the deck panel already. You should be able to shave top and bottom with it mounting from the side. You could do that technically. I mean, in the end, all you need is 3 pins, right? So technically you could cut the entire bottom and top. I don't think there's any isolation concerns per se, like from a safety perspective. I think they're quite hard, so it might be difficult to cut. But I will definitely make sure to order at least 2. And then we can try out if we can like manipulate that a little bit and yeah, shave off a bit, because it's not like a lot missing. It's really not a lot missing. Do I have it actually in here? No, I don't have it in here. I have it as a model somewhere, but it's really like not a lot that's like missing vertically. Like it's like a couple of millimeters. So maybe yeah, just cutting it away might be a solution. The other thing why I kind of don't want to have the power plug here is that I still have in mind that I want to scale the printer down. So if you want to build this with a 120 bed, then the entire machine gets smaller, right? And with the 120 bed, basically these two motors are more or less back on back. So there's no space in the middle to have the power plug. So it's like another reason why I don't want to go for the obvious solution, have it here. Yeah, so it's something to keep in mind. Potentially, I was thinking about it, having it on the side, but then like the same spacing concern applies here. Because on the side, like actually, me personally, I moved the printer back against the wall anyway, so I'm kind of annoyed, for example, with the V0 having the plug on the back, because the plug stands out this much, and then like I cannot move it all the way back. So I'm actually also considering just having it on the side. That's also like a thing I'm thinking about. Cool, okay. How about we continue? Side and elbow, exactly that's what I had in mind. Side and elbow. Okay, let's see if we can kind of like demess this. Okay, so somebody remember where the plugs go. So the twisted one is the center one. Just kind of want to get this like out of the way. Twisted center. Okay. Maybe not smart to unplug everything. Just detangle it like this. And then yeah, maybe we can just put it here like this. I do have some VHB tape, which I will just use for this. I hope that's tall enough. I think we need two strips on top of each other because the solder points are a bit too high. Oh, come on. Let me see. I had my tweezers. Where did I put my tweezers? Ah. Hiding. See, maybe we can. No, it's definitely not high enough. Let me see. Do I have some random stuff I can? Let me see my print trash. It's all like my. I did a lot of like calibration prints, as you can tell. Let me see if I have some basic. We can use half a benchy maybe. Not sure if this will stick enough. Oh. Yeah, this works. So if you ever wonder what you can do with like your benchies, see, let's grab like a little bit more. I mean, this doesn't have to be like super secure, right? It's just like, it's kind of out of the way. Maybe let's take half of this. Put it here to the bow. sure it's a perfect shape for this. I will print something nicer for this. But for now, here we go. The top is not super secure, but yeah. Okay, let's accept it for now. Okay, then the end stop cables here are kind of like temporary, right? Because we still want to move from the end stop here to a probe. But I don't think this will happen super quick. Not next week for sure. Because also for the probe we still need to like design a mount. Okay, let me see. To be honest, what we can already do today is like create custom cables for the steppers here for the bottom two that are shorter. I mean, technically we can like make custom cables for all the stepper already, because like let's not do for those two, because like these will change for the top ones, but for the bottom ones, the main board will always be quite close. So if we make like this long stepper cables, then we can get rid of quite a lot of cable stuff here. Then let me see this one. No, I didn't pay attention what I unplugged. That's good. Yeah, it's an absolute mess. Because this goes through multiple cables. Let's very briefly unplug this one and plug it directly back in. Okay. And unplug this one. Pull this apart. And before I forget where I unplugged this, make sure to plug it back in. Here we go. Okay. So this one is also, we need to see where we kind of route this, because this needs to go up and down with the bed. And then this one was, I think, the first one. You could always mount the power socket higher on the back plate where you're going to mount the mainboard. Yeah, that's like also one option. So basically these two screws here, so my idea is basically to have like, because there's quite a lot of space here between the motors. So up here we have space between the motors, and it's kind of like goes, there's basically like this like column here. And that's what I want to convert into like electronics compartment basically. And then yeah, one option is to just have the socket basically above here, basically where the main board now is, because from the depth perspective it should be fine. So we have like 5 centimeters or something, so it should be super fine to just have it here. Same issue applies with the smaller size, that you will lose basically 5 centimeters of width more or less, but yeah, still should be fine. That's also like one thing I thought about. Potentially also having it like plugged from the bottom, like not straight from the back, but like that the outlet faces down. That basically like it stands out a bit here, and then you plug it in from the bottom. I think that's also something I might like. Need to see. So, but either way, I'm gonna use the one you linked because it's small and compact. The only downside is then we need like a separate like toggle switch basically to turn on and off if we want to have that. Okay, so these are very long. Potentially we want to shorten them a bit, but slowly we are getting to a point where like this is a little bit like more manageable. Okay, twisted center and the straight one on the side. Okay, I'm actually like quite confident to quickly replace these two cables with like custom ones. I think that's a good investment of time. Then we already have like a little bit like of order in here. And I do have this like really nice silicone cable here for the steppers. And maybe we just do it like we might need to redo this at some point, but like for now, let's just do it like this. And make two cables. Let's see. Let's do the big side first. Not sure if we will ever have a stream without crimping. Oh yeah, they crimp nice. I really like silicone cables. Like silicone cables are the easiest to crimp by far. This one was a bad crimp. Sometimes when I crimp the JSTs with this like crimping pliers, like the I'm not quite sure what I do wrong, but like the end piece is not like crimped inward, but like it's over cross basically, and then they don't hold. You get a bit of a close-up view. I would say let's just crimp all the JSTs in one go. Also for the other side. Yeah, see here? Now it happened again. It's like, oh like completely weird. I don't know. Then like it's really easy for them to like pull off. Not quite sure what to do wrong there. No, it's nice. So yeah, so I'm not quite sure. Sometimes this happens. Never figured out why. Happens to me as well. I found a small pre-crimp to shape it helps. You mean like to crimp it now already before putting it on the wire? Because like I always use these just on the tip to kind of like squeeze it a bit in the back to hold it on the isolation. And then I put it in, and then it's fine, usually. I feel like it has a little bit to do with if I crimp them like at an angle. Like if I don't put them like straight in the crimping pliers, I feel like this tends to happen, but also not always. Here we go. So, let's just take fresh ones. Let's just start. There's one that has a line. I'll just start with this one. And then just put them in one by one. Let me just make sure I have them on the same side. Yeah. Now it's completely over cross here. Okay. I never pay attention to which direction I crimp the connector to. Okay. So then we have two cables that are identical. Let's quickly do the other side, and then we have two very short, nice stepper cables. And for this side we need the smaller ones, the JST-PH. Oh. Just split the cable a little bit more. Which heat block is suitable for nozzles of 0.2, 0.4 and 1 millimeter? Volcano, regular, V6 aluminum, or E3D V6 high temperature? I have no clue about that, to be honest. 0.2 and 0.4 any? 1 millimeter is quite extreme. I mean, basically any heater works, right? The question is just like, what is your flow rate of that heater? And from the flow rate and nozzle diameter, you will basically have a maximum speed you can move at. So usually the larger the nozzle, the slower you can print at. Because like the at like smaller diameters of the nozzle, for example like 0.4, often the printer motion system is the limiting factor. But as you basically move to larger nozzles, more and more the flow rate of the hot end will become the problem, and less the motion system of the printer. Oh, that was a bad one. Yeah, I was super eager to have like a 0.6 millimeter nozzle for my V0. But now in the end I never use it, because the problem is that with the 0.6 millimeter nozzle, you have to print a lot. Now it's nice again. You have to print a lot slower, because basically I have a Revo hot end in there. I just can't keep up with melting the plastic. So basically I can choose between moving at like higher speeds, which the V0 can do perfectly well, or I can move at slower speeds and have a larger nozzle. But in the end, like the print times are quite similar. Depends on speed. I actually never heard of somebody using a 1 millimeter nozzle. Like I know they exist, but it's quite extreme. I'll do some detailed prints and also some large ones where I may need speed. You mean like motion speed or print speed? Like if you want to print really large things, I remember you want to have a 350 millimeter build volume, right? I think they're like a 1 millimeter nozzle can maybe make sense. Oh, it's difficult. But by the way, you can also, like your nozzle doesn't necessarily have to match the extrusion width. So you can also, for example, print 0.6 millimeter with a 0.4 millimeter nozzle. There's like, yeah, okay, this one was completely. There's a certain range, basically, you can use a nozzle at. So if you have like 0.4 nozzle, you can use it basically, I think like 50% up and down, so 0.2 to 0.6. And that will work pretty well. On my ender, I always had a 0.5 nozzle. And then I print 0.4 or 0.6. And that worked really well. So basically I didn't change the printer, like the nozzle itself. I just changed the printer profile in the slicer basically. Last one. Okay, that's all the patience I had for crimping today. But I have the bad feeling that we will do some more. What's the largest nozzle size you recommend? Well, really you won't be going fast. It's quite a bit of plastic to push. Yeah, exactly. That is what I think too. I mean, like you can still use 1mm nozzle. The things just like the print speed will be reduced, right? But like, for example, let's say like you print 0.4, you want to have your wall thickness of 1.2mm, right? With the 1mm nozzle, you can basically do this in one pass. So you have one parameter. But with the 0.4mm nozzle, you will have to do 3. So that's basically, although you don't move as fast, your print time will be less. It's the same with 0.6, right? So basically in my 0.6 profile, I only do 2 parameters, and in the 0.4 profile I do like 3 or 4. So you just cut down on, oh, I forgot to take out the thing. So you just cut down on the distance the printer has to travel. Depends on the use. My daily drive is 0.4 on a Revo. It's a good balance of speed and detail. Yeah, I think 0.4 is quite good also for detail, because especially with the newer slicers, you can always print a thinner line width. Okay, let's see. So how do we connect this? Oh, let's actually maybe check the... I'm plugging all the steppers. I hope I remember later what goes where. So blue is the one with the marking. Oh, it's the wrong size. I thought I accidentally muted myself. Let me see. Where are they hiding? Here. So, okay, let's see. So blue is the black cable with the strip, and blue goes here on this side. Okay. Then next to blue is red. And red goes center opposite side. Then the one next to that goes one over. And the last one goes to the outside. And that's our first stepper cable. Let's repeat that one more time. So the one with the stripe goes to the outside. The one next to it goes to the center on the opposite side. It wants to go in. The one next to it goes to the center other side. And the last one goes to the outside. Second stepper cable. Okay. Then this one. Goes here. Ooh. I thought I made it quite long for the distance, but it's actually like quite close. This one goes here. Then from the top, the twisted one goes to the center. And this one goes here. And then what I would do now, let's just take them. Let's see if we can kind of like mingle them together in a way that they're kind of like out of the way. Oh no! Oh, you don't see anything? And I broke the cable. I did not pull on this. Like a bit, but... Okay. This means we do one more crimp. Let's see that I can... Oops. Get this one out. Oh, that's annoying. Let's actually replace the housing. I really don't like reusing these JSTPH. Just checking those two are the same so we can copy from the other one. I'm missing on the chat there. I found 300 by 300 size printer is the sweet spot on speed. Any faster and artifacts are just ugly. I'm planning on using a wooden frame. Will that help? I think with wooden frames you need to be careful with stiffness and that they're like square. Bigger you go, the more you have to build it like it's a CNC machine. Yeah, exactly. Like the bigger you go, the more stiff it needs to be. That's also why I'm like a little bit concerned on putting this one like one size up to the Ender 3 bed. Okay, let's see. Blue goes to the outside. Then red goes to the opposite center. Our beautiful new green goes to the same side center. And black goes to the outside. Cool. Okay, that's fixed. Let's not do this again. Let's just do it like this. Let me use one hand to grab some cable ties. Oh, and actually, I just noticed like there's very little space here between the back of the bed here and the rod. So we need to be a little bit careful that we don't put the cables in a way that they get tangled with the bed. But yeah, prototyping setup. That works. Okay, quickly clean up a bit. I had a Clayton smoking. I wanted to find out using Clipper for the firmware, or are you compiling a custom Marlin? I'm going to use Clipper. So initially I wanted to use Marlin. That was kind of like the plan. But I have to use Clipper now because we're going to install a Canvas toolhead, and Marlin does not support Canvas. So that's the choice made basically. So Clipper it is. Yeah, okay. Maybe our like benchy holder here does not work well. I'm just checking, like, I don't have anything. Oh, we also need to put the pie somewhere, by the way. Maybe the pie can go under deck. But we'll have the same issue here with taping the pie. Because I think the the solder blobs are a little bit too high. You know what? Let's just quickly. Oh, maybe we can use Wago clamps in a very creative way and glue them to Wago clamps. They should be. They have enough surface, I think. Yeah, that's better. Okay, Wago clamps it is. And it's just half this here. I think that's not how you usually use Wago clamps, but hey. I'm just going to randomly pop this here. Perfect. The pie is mounted. So, okay, then I think now would be a good time to actually install the bed, because the bed will have some more wiring that we need to like route. And then for these wires here, we need to kind of find a way how they can move with the bed up and down. I think I will just leave them quite loose, that they can kind of like find their own way. For the final build, not quite sure what to do there yet. I'll be using at a very high speed, just regular speeds. I'll use 2x2 inch box wooden frame. I keep a roll of Velcro around when I prototype the wiring. I think that's a really good idea. So you mean Velcro to stick something, or Velcro instead of like words, the zip ties, because I have exactly what you're describing. Don't ask me where, and I also like doing that actually. But yeah, right now. Nope, don't ask me where I put this. But I have a roll of Velcro, exactly for that reason. Because the zip ties are just like too permanent sometimes. Oh nice, I kind of figured it would be clipper. I'm way not paying attention to chat too much today, sorry. Kind of figured out it's clipper. What driver board is that? This is a Mellow Fly Micro 4. I chose that board because it's cheap. You get them for like 20-25 euros. It's very, very small, and I built a small printer, so the small is beneficial. It has canvas built in, and that's it. Small canvas. But this one also doesn't work with Marlin, we figured out last time, right? That was what Om was asking about last time, because this one has the RP2040 chip, the same chip that also the SKR Micro has. And this doesn't work with Marlin. Marlin doesn't support that chip yet, I guess. Yes, so basically for those, let's figure it out in a second, and then I think we will also shorten them a bit, because that's a little bit ridiculously long. And let's just see if we... I mean, it looks already way better. Much more like a managed cable. Let me just quickly check that if I move the bed down very slowly. Yeah, that doesn't conflict with the zip ties here, so that works well. Okay. Let's maybe just put this kind of like on half height. And then I have a couple of printed parts. Just move it out of the way for now. So this is basically the bed mount. We won't be able to fully use it how it was intended. Because it's just like the prototype didn't quite work out. So these were like intended to, like these are the bed clips basically. They were intended to be mounted with this way up. So they have this like temper here, and then like the deals have these like things like the nuts here to tension the bed springs. But doing it like this, the bed sits too low and collides. So we kind of have to just flip them over. But then basically it means that those don't fit. So we will just use like a normal M3 nut there to tension that. So yeah, not as pretty, but will work. The other thing I just noticed is I forgot to get out my soldering iron. So we need that for some heated inserts. So just quickly clean this one up. Was a bit too close to the bed. So let me quickly grab my soldering iron, then we can do the heat set inserts. And then we can basically need to see how we get this in there, to be honest. I don't want to take apart everything. So you kind of have to smuggle that in there. But then basically this is clipped on both sides. And then these clips go around here. And then on the back we will have one. And on the front we will basically have two. And then we have like 3 points for the bed. Okay, let me quickly grab my soldering iron. I'm back in like 5 seconds, and then I'll catch up with chat. Okay, let me quickly catch up with the chat. What driver board is that? I answered that. I can't wait to view the previous streams and catch up where you are. Well, the previous streams were quite different. So initially this was supposed to be like a super cheap build or printer. But we're quite far away from that by now. So it's quite a premium build, I would say. Lots of bells and whistles. Instead of using nylon ties. Yeah, exactly. Yeah. I mean, I have like this much, but I have a whole roll of that and I really like it. I use it in my PC everywhere actually. Yeah, it's just nice because you can open it, you can get the cable out and you can close it again. You don't have to like destroy all the zip ties the entire time. Looks like for drivers, so A, B, then Z1, Z2. Exactly, that's how the setup is. I'm guessing Canvas for Toolhead has a driver on it already. Exactly, you're 100% right. The Canvas for the Toolhead is somewhere in this mess. That's the EBB36. So the extruder will be driven from the Canvas Toolhead board. And then the main board has four drivers, and you address them correctly. So A, B, and then Z1, Z2. Which stepper mode drivers are you using? I think they are all the 2209s. I think. Pretty sure. Like the main board definitely has 2209s. I'm pretty sure the EBB36 also has 2209. Hi there, Clipper 3D Egypt, and hi Jim. Seems like there are some people trying to get Marlin to run on Pi Pico boards. Yeah, I also saw the GitHub ticket issue, but it was quite old. Like, I'm not quite sure what the problem is with Marlin running on the 2040, because yes, it's a different like architecture a bit, but I assume that should be quite easy. Maybe I'm like a little bit ignorant to like the low level programming stuff. PowerQuest 2040-42. Marlin firmware has BTC Pico specifically. Yeah, exactly. I think it's quite a cool board. I actually have one here. It's a really cool board. Like I really like it. Has everything you need, and what the Pico has going for it, and I really like, is that you have this cable in the box. This was, by the way, originally supposed to go in here. I swapped it out because I didn't want to have a separate CAN bus adapter. So you have this cable here in the box, and this can go directly to the GPIO pins of the Raspberry. And this has the data connection basically, but it also powers the Pi. So this one has like the step-down converter here is strong enough to power the Pi, which is really nice. So you don't have to worry about how to power your Pi. It's a really nice board. I'm printing a PT puller to make filament out of bottles. What do you think about printing with bottle filament 260 Hito? I never tried it, but I think it's a really cool project. I'm not quite sure how good the print results are. I think I saw some good ones. But yeah, it's like it's a project. It's definitely a project. I think it's a lot of work to like make it work, or like a lot of work to like get it work reliably. But it's definitely really cool. Main problem for me is I don't have PET bottles. Like I rarely buy rarely buy water in the supermarket, so I don't have a lot of PET bottles I could use with that. I also saw somewhere the same people that did the PET bottle recycling thingy that you're referring to, they also start working on a very small filament extruder, like that you basically can like recycle your own filament. because at the moment, like I always, like I collect everything. I showed this bin before. Like this is my PLA bin, and I actually like send it off for recycling since a couple of months. Form Futura offers that in Netherlands, so for me it's like super cheap to like just ship them like a large box with all my PLA stuff. And I kind of feel better about it being recycled. But it kind of would be fun to do it myself. The downside is it has a tendency to be a lot of work, I think. What are benefits of using Canvas? Canvas basically is, I mean, if you run Clipper and you want to have multiple boards. Oh, I did the thing again where I like didn't lower the temperature and now like the ABS is burning off. Healthy fumes. Let me get this kind of like over there. So if you have Clipper and you want to use multiple mainboards, you can do it basically in a couple of ways. The easiest one is to have USB, right? So you can just connect multiple mainboards via USB to your Raspberry. That works, but USB is like a little bit painful in a certain way because firstly, the cables are quite stiff. That's one thing. So they're just a little bit painful to route in your printer. And you cannot easily shorten the USB cable. Canvas is the other option to connect mainboards. And it has the benefit that it doesn't need shielded cables. So a Canvas cable can just be two wires. So this can be a Canvas cable. You just need two wires and they're supposed to be twisted every 20 millimeters or something, should be one twist. But besides this, like basically any cable can be Canvas cable. The other benefit of Canvas is you can chain clients. So if you have multiple boards, you can just chain them along the canvas. So for USB, you would need a USB hub, right? To have multiple devices on one USB port. And for Canvas, you can just literally use like Wago clamps and like have multiple CAN devices connected to that. So there's no requirement to have like a hub or something, which is definitely neat. And then the last thing that I'm aware of is, but it's more like a theoretical thing. Canvas is supposed to be more reliable when it comes to timings of the communication. But I'm not quite sure if this is really relevant for daily printer use, to be honest. I think that was already all the heatsink inserts we need. Yeah, and then what Steve said, if you have Canvas for your toolhead, you only need 4 wires to your toolhead. You need like a 24 volt typically and ground, and then CAN high, CAN low. So you have 4 cables, and all your electronics on the toolhead are connected to the toolhead board. So instead of running like a million wires, you just run those 4, and then like, yeah, you don't have anything else to worry about. We will set it up in a second. Let me get the bed done. Oh, it's good. Yeah, it is a bit short, so we can. I'm not quite sure where I like tightened those screws yet, to be honest. Oh, and we forgot some heatsink inserts. Oh, yeah. Oh, I thought it was a bit. There's still some more. Yeah, but like I'm definitely a huge fan of the toolhead boards. I don't want to have a printer anymore without toolhead boards. CAN toolhead board is definitely the best solution. Or also USB, like I think in that regard it doesn't like make a huge difference. Also USB is fine as a toolhead board. But it just cleans up your wiring of the printer so much. Like if you have to run each and every cable from the main board all the way up to the toolhead. Like it's just like it's a lot of wires. Actually see the music stopped. I think I didn't set it to autoplay. I did not. Okay, now we have all the heatset inserts. Okay, let's just loosely just see if I can kind of like give you a little bit of a side view for here. Yeah, I remember like these were not printed properly, like there were some supports missing here. Gonna have to clean out those screw holes a bit. I'm not tightening that yet, I just kind of want to have it in place. Same on the other side. Slowly running out of screws. Okay, let's add the centerpieces here. And as mentioned, basically there's designed to go in this way with like, I actually made this like little indentation for the spring here. And then with these like twisty thingies on the bottom. But basically that's not working because like the bed collides with the corner pieces here. So we kind of have to flip them over for now to make it work. But yeah, that should be fine. Yep. And these are the last two screws. Let me quickly check. I need to get some more. Also here, I'm not tightening that. I'm just like kind of like attaching it. But I think it will be quite. We can slide it around. That's okay. Cool. And then there's one more basically, and then we have 1, 2, 3 connection points. Should get the printed out of the way. Let me see. Nope. I do have my magic. I think they're in here. And I only see silver hardware. Oh, but while we are here, these are different sizes. I accidentally ordered like 500 heatset inserts, or 1,000, 500, a lot, in the wrong size. Don't do that. It's quite stupid. I still have to find a use for the wrong size. I think like when I do some like hobby projects that I design myself, I will just design them for the small one and like slowly use them up. Okay, no black hardware here. Let's see. Oh yeah. This is the bed, and it comes with with the screws we need attached. Very convenient. but not a lot of them left. Maybe I have to order some more. I thought I ordered so many screws I would never... I ordered screws specifically for this build. And I thought like, are so many, I would never use them up. So I find it a bit irritating that the deck panel is transparent. For the switch wire, I have a transparent bottom panel, which I find really cool, but the deck panel transparent is a bit, like it would be much cleaner if you don't see the pie. Okay, so moment of truth. Yeah, I also removed the cover here because we need a 45-degree thing, but I didn't print it yet. So that's kind of like more or less where the bed goes. I do have one spring. Here I have two more springs. So I have springs. And I also should have some of these long... Here we go. And these are socket, not socket, the countersunk. I forgot the name. The countersunk ones. How's SK 1.4 with the TMC 2008 for my Core XY 3 German budgets? I think the 1.4, I don't know. I mean, sounds like a fine choice. Let's first actually like align the things here. So I'll just punch the screws through, kind of like, just make sure that these holders are kind of like in the right spot. It makes sense to loosen the screws here. So we can actually move that. Wow, like it starts looking like a printer. Okay, now this is kind of loose. Let's just make sure that the distance here, left-right, is the same. So I'm just gonna quickly, I mean, the exact distance does not matter yet. And we can try to move this up quickly. And just see how far forward like the nozzle goes, basically. Then basically we can use that to adjust the front of the bed a bit. Because there's not... Oh, yeah, that's what I meant. There's a bit of like a collision there. Here we go. So I think something like this should work. I'm just tighten one side here. Okay, and then I just take the calipers and then basically I just measure that. And then you can use a little screw here on the side to fix it. And now we can just copy the distance to the other side. And now they are the same, ideally. Okay, so from left right, this looks kind of okay. SKR is a good board. I have a Warren built 3-4 years ago that had 2 in it. No issues. Are you following some plans for your builds? Yeah, it's also like an interesting question, because like you seem to have like a lot of ideas around your build. Okay, this is now a bit difficult. So basically, that's the problem I mentioned. So we are kind of like touching these corner pieces here, which is a bit of an issue. That's why we had to flip them over, and with the springs it should be just fine. And actually, like, this seems to be like a fine position actually for the rear ones already. So let's just again like lock one side in. Let's just lock one side in and then copy the distance over to the other. Okay, we still have to tighten these here. These are tight already. Now we can just tighten the ones in the front as well. Actually, let me quickly use this one. That's much nicer to tighten stuff like that. Still finalizing the parts, okay. Oh yeah, also here, like I still printed in the accent color, but I'm kind of like slowly running out of this accent color. So I decided for the prototyping parts, I will mostly stick to black for now. Because I don't like the material too much, the turquoise one. So I'm not super eager to buy a second roll of that. Okay, let's get this off. Like the screws are binding a little bit with the holders here, so maybe it's smart to quickly drill that out. Oh, it should be fine, I think. And actually, like, we don't have to like move this bed out that far. We just have to add the springs. And we have a bed with springs. Let me look for some M3 nuts. But to be honest, the screws are quite long. I do have these spacers, so maybe we can combine that. Oh, we didn't tighten yet. We didn't tighten these screws yet here. That would have been quite important. They're not 100% center. I think it's, yeah, it's fine for now. Not very concerned with like having the maximum build volume for now. Is the 600mm cubicle frame too big or enough for my printer with 300? Sounds pretty big. I mean, it's almost double. I was like, yeah, almost double. I would advise you to just look at the Voron 2.4, for example. Just check the dimensions of that and what like frame sizes that has. That's also what I do here. I just try to copy like things that exist already in a certain sense. It just makes it much easier. Okay, let's try this spacer. Let's maybe actually put the printer on its back. Because this should allow us... Yep, now we can still use our thing. Problem is, I'm not sure where the third one is, to be honest. I have two here. Need to check in the box. I mean, again, like these parts should be like flipped the other way, and then you wouldn't need these spacers. Spinning a bit too easy. That will most likely mean that it will be very easy to like accidentally change, or like that it changes itself. Let's see. Here's the... oh, this one we can maybe also put back the connector. Where's the third one? I see. Way too much chaos here. Where's the third one? Otherwise, we use a nut for the last one. Let me check one more. Oops, one more box. Also not here. Okay, I really don't know where I put that one. Okay, then let's use just a nut for now. What access height do you recommend? Well, depends what you want to print, right? Pretty sure we will find this like third one in a hot second. So for now, let's just use the same spacer, a washer and just a nut. And now looking at this from the side, I think we need to move this one a little bit more forward. Let's quickly do that. Let's just loosen these. Warren outside dimension is 510. Yeah, something like this I had in mind. I know it's below 600. Because I have, I want to build the 350 next year. Let's just do it like this. Does it look straight? Yeah, this looks about straight. I want to build a 350 next year, and the cabinet I want to put it in has like 600 width internally. And I know it fits in there. Okay, let's quickly use the trick here again to copy the width. Here we go. Let's quickly see if we can get the cable cover thing on. Let's not entangle our soldering iron in our cables, maybe. Might just be enough. Oh. There's a nut on the bottom. I quickly have to hold the nut with the pliers. Yeah, but I think we cannot put it on. If I put this on, where is it now? Oh. It will limit us a lot in how far we can move the bed down with the springs. 600 is a good enough as it as a customer. I think you can go for 600. It's a bit over dimensioned, but I mean it's better to have more space. Yeah, like this one doesn't work. There's not enough like clearance, so let's see what we do with that. Let's just tighten it down for now. And then I would advise to not touch that. Let's see how we need to design custom cover. But later on, the bed will sit a little bit higher, then we also have more clearance here. So I guess later we'll be fine. Let's just be careful for now. Should be fine. Okay, then also we can now where does this that's coming from the I found a random nut. I was like, where does this come from? It comes from here. It's holding these two parts together. Still a bit sad we don't have the third tension thingy. But to be honest, we can not touch this one and just adjust the front ones. And that should also be fine. Okay, so for the bed, I think it's best to just leave it like, kind of like free. This is like an open sleeve. So what we can do is we can route the end stop cables through the same sleeve. Put my soldering iron cable through one of these end stops. They're a bit annoying cables. So let's just see how we can route that. Let's do this one first. Just get it through here. And just put this here. Oh, you don't see anything. I'm so sorry. Draw up what you are building on paper or in CAD. Only requirement is all your parts fit in. Yeah, exactly. To be honest, it's quite easy with Fusion to like put stuff like this together. I would highly recommend just like making a rough Fusion model of what you're doing. It'll make it much easier. Because like most of the parts will exist as 3D models somewhere. So you can really just like pull in existing 3D models and arrange them basically. Okay. Let's also directly put this in. Then we just make put a zip tie at the end. For that, I'm not super concerned about like cables moving. I mean, for now it's again prototype. It just needs to work in a certain sense. Doesn't need to work reliably for the next like 5,000 hours. Let's push that all in. Cool. And then just to lock this in, let's use a zip tie. This should be fine, like can kind of go around the belt. And that's quite a reasonable length. We need to figure out which one are for the heat bed. And then I would suggest we shorten the end stop cables. And then here, this one has like some Prusa specific connector. I don't think. I mean, it does fit somewhat on. Let's just crimp this as a JST. And then recrimp the end stop cables. And then I think this is kind of like okay setup for now. The screw terminals will kind of like hold the main cable here in place. Let's just quickly, yeah, let's check the screw terminals. What goes where? Which one was the documentation? Translate to English, please. Oh yeah, this was the in progress. They don't have like a pinout? Oh, it's the same page. Is it? Yeah, it's the same. Let's quickly see Mellow Fly Micro 4 pin out. I know the pins are like written on the bottom. Is this just random? Yeah, it's a random board. I've seen the pin out. I know it exists. Okay, let's just, pretty sure it's on the AliExpress listing. Here we go. So the bad are the center two. And then let's just be politically correct and don't swap the plus and minus. Oh, no, the cables came out. Let's also right away put a cable tie on the bottom end of this. It is quite packed. Okay, let's get rid of these like end stop cables. I'm kind of annoyed. So these two are one plug. Let's do our most favorite thing and crimp some connectors. I mean, haven't done that in a while. Could have kind of like at least cut them to the same length, right? One. With a tiny bit too much isolation. Did not press it on enough. Let me use a new one. And it's again like one of the bad ones. I don't know why this sometimes happens. But it's on quite okay. Let's leave it. Okay, 1, 2. Oh, this should have been like a 3-pin. Pin. Can I save it? Come on, I don't want to make... Here we go. One saved. Second saved. Whew. Okay. Let's quickly recycle the one we had. So they go in like this, and then one is here. Oh, wrong way. One is here, and one is in the center. Okay, that works. I'm just wondering whether it would be smart. Not sure if it's quite long enough. Whether we like zip tie it to the rod here on the bottom. Maybe we can shorten this like isolation part a little bit. That would be better than, like, at least it's like connected on the bottom and doesn't pull on the main board. Let's do this. Actually, let's keep this H thingy there. I like that. Then I think that's just a 2-pin then. Let's quickly double check in the pin out. Yeah, the temps are 2-pin. Okay, and this one, let's just cut this like to the same length roughly. And 2 more pins. Again, this one again like doesn't really, you know, it's they're quite on. So let's leave it like this. I will leave this in here just as a marker for me. Let's go use a new one. So one is on the outside and the other one is in the center. Okay, let's move the bed all the way up. So I think the cable is long enough that we can basically just get this out of the way here. Really like put it just here. Problem then is, so we should definitely shorten the sleeve a bit. I just try to like wiggle the zip tie a bit back. If we shorten the sleeve, we will have like an easier time wiring everything up. Sure to not accidentally snip any cables. That would be really awkward. Here we go. Now we can attach this here. And then we can still route everything where it's supposed to go. Files. Hi there, Roberts. I was wondering where I can get those handy screw storage boxes that you use. You mean these? They are on printables. It's just a Gridfinity system. It's just a Gridfinity system. Give me a second. It's this one. This is the box. Oh, by the way, I totally forgot to I felt like when I started the stream, I forgot something. What I forgot was the stream. The chat. Nobody complained. Here's the chat for you. So Roberts, that's the box. And then you can just use any Gridfinity containers. So yeah, there are like a million of those on printables. I think they're 6 units high. So this is like 1 by 1, and then this is 3 height. So 3 is half, and then like 6 is full. Yeah, and I use them for, yeah, this one is like, I need to fix this. Like this one kind of gets stuck here. Yeah, but I use them for crimping and for screws and everything. They're really cool. I started doing that because I had like, so the gray filament, I had like 2 spools, and I didn't want to use it because it's not like really good filament. But I kind of got it for free from a friend. So I had 2 spools, 2 kilograms of gray PLA filament, so I started printing these. And then the center ones, whenever I have like filament left over, like I have like 150 grams of filament and I just don't want to use it anymore because I don't like the, I'm just done with the blue, I don't have use anymore, then I just print boxes. And when I started doing this, I had like a couple of filaments like lined up like this. So I just used it to like print boxes in random colors. I actually now like the red one here. This one I bought, I got a voucher from like Amazon. I was like, what do I do with Amazon voucher? And then like I ordered like the red filament and some other one, I forgot. And I ordered them specifically to print on those boxes. So I have like 9 of those things in total now. Okay, let me tighten that good. Let's see if this works. I mean, we can even, to be honest, now we can remove the front zip tie here. And then we can actually like, I'm not shortening it more. Maybe we need it. But now we can do this. Button tube extruder or direct drive. With the dimension you're going for, direct drive. There is no question. Like in general, Bowden is the inferior system. It has one benefit, which is it reduces the weight of the tool head. So if you go for like ultimate speed, yes. But besides that, always Bowden. Always direct drive. It's like putting a little bit of pressure on our like very weak mainboard mount. I most likely design like a small mount for this mainboard that we can glue it a little bit better, and don't use Wago clamps. Okay, cool. Then let's do the rest. Yeah, well, I'm not sure which end stop is now which. That's not super smart. And the bed temp is the one closer to the steppers. So it's this one. This is the bed thermistor. Yeah, that's just, we most likely have to 50-50 chance that like the end stops are in the right order. Oh, we can do it. Here we go. And this one, let's route it on the outside. Quickly recycle this one. Okay. Cool. I feel like we're making quite a bit of progress today. Cool. I mean, that works okay, I guess. And where did it, like, somewhere the cable just like got caught? Short. You can like pull that in a little bit. I think I'd rather route that this way around the belt, because then it doesn't collide with the motor here. Pull it a bit back. Not perfect, but oh, actually, I have a zip tie position here. Maybe we can route it between the belts. Oh, that also works. There's a little zip tie loop here. Let's see if that is functional. Oh, it is. Nice. And let's up. Bit tight. Should definitely increase the size a bit. Perfect, and this can go through here, and then basically that is kind of cleaned up here. Oh. I forgot to change the headset side. Okay, I think I'm back. OBS crashed again on me. We had that before. When my battery of my headset runs out, we are in very dangerous waters. One second. Let me get everything back where it should be. I need a second. I mean, it wouldn't be one of my streams without some technical glitches. Okay, I think the music is gone. I don't know if I can fix that, but yeah, I guess we have to live without music. Could be worse. Hey, okay, cool. Sorry for that. Then, where were we? Oh yeah, zip tie other side. Let's also maybe try to zip tie the other side. So we just kind of show you what I'm doing. So there's a zip tie thing here, and then I wonder whether we should do something about these. Like maybe we can just twist the cable a bit. At least they're like kind of like together. And then we can put this here, and then like it's kind of cleaned up. I don't have, oh no, I do have one more of the small zip ties, I think. This one is like smaller. This should definitely fit here. Let's see. Yeah, that's through. Have you built a resin 3D printer? No, I don't have resin. The reason is that I don't have a dedicated space for printing. Like I only print in my living room. And with resin, you have like, you shouldn't be in the same room as the resin printer when it's printing. Because it has like fumes that are quite bad. Oh, yeah. This zip tie is definitely like a bit too large already. Okay, here we go. Yeah, I don't have a dedicated space, so I can only have 3D printers in my living room, and I don't want to print resin in my living room. I thought about getting one at some point, but that was the reason why not. But to be honest, I also don't think it's extremely useful for, like, depends what you're printing, right? So for me, like, I'm mainly printing mechanical stuff, like printers and other things. And for that, resin printers are not as useful. Let's see if we get, oops, a tiny bit more of the cable here. Maybe we can zip tie these two to the bottom here. Let me see. I want to have a bit more of this cable. Yeah, okay. I'll leave them loose here. Cool, okay. But I think then we kind of are all cleaned up. So what I would do now, let's just turn it on and check everything is still working. I'm not confident with the stepper cables and the end stop switches. So we just have to quickly run through our setup routine again. And then we can also check that the bed thermistor is working. So yeah, we can do a couple more things. And if that is all working, we can start working on the tool head. So, oh, we actually have to do one more thing before we can get started here. I think for today, I will just power the Raspberry externally again. I do have some buck converters. Like these are quite cool. They're very tiny, and they take 5 to 30 volts as input, and they give 5 volts out. They are supposed to be able to deliver 2 amp, which for the Raspberry Zero is enough. Let's see how it goes on long term, but I will just try them. And basically what we can do with this, we can basically just make a wire that has this like inline. So we can directly plug it into the power supply and then power the Pi on the other side with that. But for today, I think I'll just use USB external to power that up. So let's just connect it here. And just because I know myself, let me also quickly zip tie this cable here, that in case like I pull on the cable, we don't pull on the Raspberry. Okay, then that's basically all the cables. We need one USB-C cable. Which this one looks quite fitting, right? So this basically, oh, it's actually one that came with the board. How nice. Oh, we could have put this through the, let's also do the same here. Let's plug this in first. And then just fix this here. Maybe I could have done like an extra loop. Yeah, that's, yeah. I don't care for the yellow zip ties a lot. I find them quite ugly, so. Let's do it like this. And although this is a USB cable, the actual MCU, like the main board in Clipper, is configured by a CAN bus. Just put this bit on the back, that like we don't put it on the cable. Cool. That's it. So now we are wired up. We need one power supply and one bigger power supply. Maybe also let's do the same a third time. Like these cables will later go like under deck, right? So for now they don't, but let's also put them here. And we kind of have this all secured. Zip, zip, zip. And for now, these go like out. Then let's connect power. Our very makeshift power setup here. I can't wait to make this more permanent next week, hopefully. Yeah, and basically we need at least one like Wago terminal. Basically, I have these fiber blocks here. I will most likely just glue them with double-sided tape, like to the side or something of the power supply, because we need at least 3 power connections. We need it to the Raspberry, we need it to the main board, and we need it to the Toolhead board. So the 2 terminals we have here for positive and negative are not enough. Yeah, and then I think the best way is just to use the Wago terminals to extend that. And then we also have like 2 more free. One more free for something else. Okay, let me plug this in. I switch off the outlet here, so we can later control the printer power like last time. Good. See how to put this here best. Like this. Perfect. Cool. Okay. That is our 24 volt. Then we need to do this. I'm also, like last time, I'm very hesitant to plug this into my MacBook to power the Raspberry because expensive. And I don't trust electronics at all that I had my hands in. Soldering iron over here. I don't think this is long enough to reach anymore. How did we do this last time? I remember we had like a good solution last time. I think I just plugged it into the end, to the socket on the wall there, but that doesn't reach anymore. Okay. I might regret that. Let's power it via the MacBook. No, it's not like, no. I don't do that. Then I have a power problem. Your plugs are terrible. The UK 3-pin ones are better. They are also 3-pin. That's. I think that's a stereotype. Let me educate you. 1, 2, 3. It's exactly the same like the UK one. And that's protective earth. It's exactly the same as the UK. It's just smaller. We do have, in fact, also these plugs, and they don't have protective earth. But these are only used for low power devices. So there's a certain rule, don't ask me. This says now 2 amp, so it would be maximum 500 watts. But yeah, any bigger device uses these. And I know the UK doesn't have the small ones, but to be honest, I think there's a case for the small ones, because you don't want to have like huge plugs on like all your small devices. But yeah, like all the bigger devices that draw more power all have to have these. And this one is 16 ampere, so basically, yeah, a lot. But yeah, it's a stereotype that our plugs are 2-pin. Here we go. The UK ones don't let you plug until ground is connected. It's the same there. Ground connects first. So you see, basically, you have the metal on the side. That's the same as the ground pin here. In fact, by the way, we don't have this as a pin. The Swiss have it as a pin, so there's a pin coming out. How can I, yeah, let me show you. Oh, actually, this would also solve the issue I have. No, it doesn't. So the socket looks like this. You have these like connectors here, left, right, and they make connection with the metal strip here. So basically, when you plug it in, now you already have ground, but the pins didn't even insert yet in the holes. So you have the ground connection before you have the electrical connection. So now it's already grounded, but there's like no electrical connection yet by a long shot. And also, like what the EU plugs prevent, they only will connect, also the smaller plugs. The electrical connection is only made when they're so far inserted that you cannot put your finger anymore between it. That's a big thing with the US plugs, I know, because the US plugs are horrible. I think we can agree on that. They make connection before the plug is fully inserted, so you can like really like put something on the live connection. But with the EU one, that is not possible. Like you already see, like there's now no way you get your finger in here. So yeah, that's EU EU outlets. They are pretty good. It's I know there was one of those like very common myths that was told in the Brexit campaign. But our EU plugs are pretty good. The US, I actually got I got a shock once from AC voltage, and that was with the US plug. Bad one at that, but so. Okay, let's plug this in here. Now that the switch is a bit closer. Still not sure what to do with this. I think, let me quickly grab like a second extension cord. Give me 5 seconds, I know where I have one. I'm right back. Here I am with the power brick, a second extension cord, and a solved problem. Okay, so Raspberry and mainboard are powered. You already saw the blue LEDs turn on. Let's give this a second to boot up, and then we can connect to the web interface and just run our checks. I think first we should check that the end stops still work and that the end stop are with the right motor. I'm not quite sure if we can check that. I think the end stops should, yeah, we never swap the end stops. And then we should test the Z motors if they're still correct, because we swapped the cables there. And if that all works, I think we're quite good. Technically, you can already start calibrating the Z offset, but I don't think that's gives a lot of benefits so far. Okay, let's see if that is already on. Main sale.local. It's loading. Nope, not yet. Here we go. Cool. So that's on. Let's quickly head to the machine and query the end stops. So they're all open at the moment. So I'm depressing one. Okay, now that is triggered. And Z1 should now be triggered. Yeah, exactly. So the end stops work. That's great already. Let's do a quick stepper bus. We have a stepper bus here. Stepper bus, stepper Z. So now basically I would expect this one here to move. It does not. Oh, yeah. You know, would have made sense to give it power first. Okay, so this is the magic smoke cam. 3, 2, 1. One more LD, no smoke. I think that's good. Let's try the stepper bus again. So basically we would expect this to wiggle. Oh, it's this one that wiggles now. So potentially we swapped the thing. So this was Z. Let me quickly compare that with the end stop. So if I press this end stop, we have Z1 triggered. So the end stops are definitely swapped. So we need to quickly swap the two end stops. Usually I prefer turning it off, but for end stop swapping I'm fine. Okay. So now this is Z1. Okay. End stops are switched. So let's quickly do a stepper bus on Z1, which now should be this side. Yeah. You can see it wiggle. There it wiggles. Cool. Okay. Then I'm confident that we can do a Z home. I kind of saw the plexiglass. Oh. Oops. There was a... I mean, it works. It's not great. So our screws there don't work. I just saw like in a camera like how it like, I mean it should be fine. Okay, so maybe we find a shorter spacer, because I don't think there's like a lot that's missing. We are missing 3 millimeters. So if we shorten the spaces, 3 millimeters should be fine. Go for broke, print a benchy, no testing. There's some parts, some essential parts are still missing here. But I hope next week that we can do some printing. That would be really cool. Okay, so that Z is, oh, but also like the Z tension is completely off. I don't know what happened here. Like this is, there's no tension here on this one. Yeah, not important for today. But we learned we have to loosen the pulley on the back to do the Z tensioning, the belt tension. So, but there's no tension on either side. Maybe something changed, doesn't matter. We have to do it later. Anyways, let's quickly do, but it means our stepper cables work, right? The stepper cables work, so I'm quite proud of that. We didn't change anything for X and Y, so let's just home. That did not work. Stepper bus X. There's a little bit of a bus here. Stepper bus Y. There's definitely a different bus here. We had that before. We had that with the wrong cable. Do we have the wrong cable? Blue, blue, green, red, black. No, the cable looks correct. But the behavior we had here, we had last time when the cable was incorrect. Huh. Let's check the cable then. Let me turn off the motors. If we turn off the motors, we can unplug that. This thing is going burr. You should have seen it last week. Like we did the speed test macro already. It went quite well. Like we don't have like high amperage at the moment because we don't have any cooling for the stepper. So I only have it at 0.5 amps or something. But it went quite well. Also, like these parts, we need to like redo. Like I cannot fully tighten them at the moment because then there's too much pressure on the again words. Not bearings, on the bearings. Same here. It's like we cannot fully tighten it, so it was a little bit like wobbly, but yeah, it works quite okay. I'm back. What did I miss so far? Well, we have a bed, Paul. We now have a bed, which is like preliminarily mounted. We have electronics on the back, which are preliminary, like all prototyping phase, but it works. And the Raspberry is also glued in here. We can home that. Let's actually move that up. I want to see the cable here. And actually, Z is really fast. That's one thing that definitely is the case. Let me just carefully. Okay, so we can definitely. We are now at -1 already, and there's still like quite a gap, so we can extend the Z range a bit. But also the cable here kind of gets now like a little bit short. So maybe we have to redo this again a bit. Yeah, I'm pretty sure like the cable can like support like another bit of movement. So that's fine. But yeah, the bed is quite speedy. Cool. So that all works. We just need to figure out what this stepper here, what the problem there is. Oh yeah, and that's a problem. Like that hits the deck panel now here when homing. which I think, yeah, to be honest, I kind of would ignore it for now. It's most likely when we shorten the spacers here, we'll be fine. I'll just print like new spacers that are shorter, and then should be a-okay. Okay, let's check the stepper. So the weird bus we had with the wrong cable. Now my question is because we had to like fix this cable here, right? Is this all correct? So if we compare that quickly, we have blue, green, red, black. So the order is the same. Also here we have blue, red, green, black. So the order here is also the same. So I'm not quite sure what the problem would be, because like the cable seems correct. Cable seems correct. If I do the stepper bus, like you can basically see it buzzes. If I do it now, you see like it's a very short, very abrupt buzz. Oh, that's excellent cable idea. Let's swap them. It's just like the cable here now is a little bit too short. Just to show you the other side. So if I buzz this one, you see it's like a very longer buzz. Okay, let's swap the cables, but this means we have to kill the zip ties. I don't know who talked about Velcro strips. That would be excellent now. Actually, I have like 2 Velcro strips here. Let's replace the zip ties with Velcro strips. There's no power on the steppers. Never unplug the cables of steppers when there's power on the steppers. Not good. You will get like sparks and stuff. That's not what you want. So now we buzz X again, which is now this because we swapped it. Yeah, see now we also have this like weird buzz here. There's definitely something with the cable. Dum dum dum. It's definitely something with the cable. What could that be? Let me quickly check the crimp we did. Not a good crimp. Not a good crimp. I'm not quite sure if this makes contact. It should, to be honest. No, it should be fine. I was a bit concerned here that the isolation goes quite far forward, but like the tongs here still grab on the bare wire, so that should be fine. Let's leave this one out and just see what the stepper does if we buzz it like that, if it changes anything. Just make sure this doesn't touch anything. Don't do that at home. Okay, so now this is without the green cable. Let's just see what this does. It produces exactly what we saw. So I think the green cable is not okay. Produces exactly what we saw. Let's try that again. I mean, the green cable is a tiny bit shorter now than the others, right? Because we had to like cut off the original crimp. So maybe it wasn't fully seated. I shouldn't do much. Let's separate the cables here a bit more. Just to like relieve a bit of pressure. Let's try it again. No, it's still doing the same weird stuff. That's weird. Didn't expect to have to debug something as basic as a cable. So if I now do Y, so I put the other cable in. That's what it should do. Bad cable or bad stepper driver? Why would the stepper driver be bad? I don't think this is typical for a stepper driver issue. Let's test it. I swapped the cable, so we now can bus X. Looks fine for me. So it's really it's 100% this cable. 100% this cable. But don't see. I did crimp this myself, by the way, right? I remember I crimped this, so. It's not a pre-made cable, but still, like, it looks. I don't see what could be the issue here. To be honest, like it's just a cable. I crimped like a million cables. Aha, okay. The blue cable broke. Black is fine. Green is fine. Red is fine. Okay, so blue had the same as green. So seemingly somebody, definitely not me, did some shoddy crimps. Wonder who that was. Test it, Steve. I'm pretty sure like this is the. Let's quickly replace this and try it, and then I'm somewhat confident that it will work. Here we have a crimp. Let's put that bad boy in. I crimped the wrong one. That's the wrong size. Okay, like this cable is now getting like even shorter. And you are blaming it on poor cable. Well, true. It's not the cable's fault, it's the connector's fault. But I think the intern doing the crimps here will not get a pay raise this stream. Okay, like this looks now a little bit wild, but let's test it. this cable, again, like don't disconnect those stepper cables while the steppers are active, or like not moving necessarily, but like holding, because you will get sparks and you can kill the driver. But if the stepper driver is off, you can unplug them somewhat safely at your own risk. Okay, let's try this again. So now everything is back. So this one up here should be buzzing. Yeah, now it sounds better. Wrong sides or upside down? Upside down, I already gave up. Okay, so we now have this bus. Let me just double check. I kind of want to see it again. And now it's doing the same again. It's doing the same again. Wait. If I just to compare to Y. Yeah, it's definitely it's still not working. Okay. Desperate times need desperate manners, desperate measures or something like that, right? Go out of here. We do that again. Let's just start over with this because I'm pretty sure it's the crimps. Almost lost my screwdriver there. See, nice. I thought we would work on a toolhead today. Optimistic how I was. Sure, cable does need a software update. I'm not sure. I also didn't try turning the cable off and on again, right? That also always helps. Okay. That looks okay to me. Two more. And then I want a perfect stepper bus, please. It's not damaged. Yeah, that was not good. The green cable found its way into the jaws of the crimping plier. Pull out, but then like I lost the crimp. Let's try this again. So it's this thing with like these like bundled cables. It's so easy to like damage the others while you crimp one. Okay, one left to go. Here we go. Okay, let's quickly take a new one. I will like the problem with these JST PHs, like you can basically not reuse them at all because like they're these like plastic noses. If you like move them out once, they're basically not secure anymore. Yep. Green one doesn't want to. Okay, let's see what we can do about the green one. Not wanting to cooperate. Also, black is a little bit tough. There we go. Okay, it's in. Quick tuck test. Tuck test passed. Double check. Blue, green, red, black. Check. Let's not mix up our motors. Okay. New cable, new luck. Let's try this again. That looks good. Cool. Success. Okay, so one, don't ask me which one of them was not really good. Let's quickly see if we... Okay. This works quite okay, then let me put this back. Okay, last one is of course okay. This goes back. So. Okay, then with a little detour we should be ready to home everything. So now when we home X, it should move. Yay! Why? Yay! Z? Cool. So now we can move it to 90, 90, 0. And hey, that's something. Like the bed is quite far off. Like there's quite the gap between the bed and the nozzle, and the bed is supposedly at 0. So that needs some tuning, but we also have like quite some room here left to move up. But I think that's for next time when we start printing to figure out. Cool. Also now here there's a bit more, okay, something is a bit off with the tension. Now there's more tension here on that, but it's also for later. And also what I've discovered, there's some adjustment issues that we need to take care of. You see, like there's like black dust, so the belt drops on the pulley or on the idler. So it's most likely that this one is not adjusted correctly. We didn't adjust them at all yet. So I assume this needs to be a little bit down, up, that we get rid of this. But yeah, also not super important for now. It moves, so that's the important part. Cool. We have a printer. It moves. It has a bed. It has almost everything. So what I would do now is I would start building the tool head. We can do the fans, we can do the wires, we can do the tool head board. The only thing we cannot do is the extruder gear. But yeah, that's basically next time we have to partially disassemble that. But so like if we can get like all the wires done today, I think that's really, really good. Let me shut it off. Or for the fun of it, let's move it a bit. The tension will always move from one side to the other as you go up or down. Aha, yeah, Steve, I think you're correct. That is a fair point. Yeah, but now it's like no attention at all. Yeah. It moves. Also, like the really bad vibrations we had in the beginning are completely gone. Also, like last time when we ran it without the micro stepping, like the vibrations were not there. Like in the beginning, like first time we ran this printer, like when we had this move to the side, we had like really horrible vibrations. And I think like since we added the bottom part, it's like way stiffer, which solved that issue. But to be honest, like this like cable here on the back for that, like this works really well. That works really well. Cool. Okay. Let me turn it off. Let me turn off the steppers, and we can like flip the switch, and then we can just take this off, I think, and then build it on the table. Yeah, and it's also something like at the moment we didn't tighten the screws here a lot, but like this is really wobbly. I mean now especially because I loosened the screw. So potentially this is something we need to adjust here by making that wider, which would be quite a big change in the design. Let's see. Okay, but hey, I'm really happy with that. Oh, before we now start with the tool head, also let's turn it this way. Let's tidy up those wires again. Oh, you know what? I accidentally pulled here a bit in the beginning, right? When I cleaned up the wires, and then like the green one popped out. Potentially I just damaged like more than the green connector there. Oops. So see, something like this. I do have one of these Velcro strips. Oops. Stay with me. Here we go. And I actually have two. Three, like different ones, but who cares? Oh, and actually, I prefer having zip ties on this one because there's not a lot of like clearance here. I rather have a zip tie because it holds it tighter than the Velcro. Let's do zip ties. One on the bottom. Let's do here one center. Okay, that's not a good spot for Velcro. Cool. Oops. Oops. 3. That's it. The tension will always. Oh no, I read that message from Steve already. I thought it was new. Cool. Okay, then let's park our amazing printer. That like really like slowly starts looking like a printer. I did not expect that at all when I started. Here we go. So we need some stuff here. Firstly, we need this screw to kind of come out. And these parts are quite, oh wait, they're screwed together, that's one thing, but they're also relatively tight. So the only thing we need to do are the fans and the hot end cables. And the hot end cables we most likely need to extend. Okay. Oh, to be honest, we wouldn't have even needed to take this apart because like it's really like all we need to do is like in the bottom area. Okay, let's see. Fans. These are 24 volts. I have relatively cheap fans because like yeah, I started out as like a very low budget printer. Then kind of evolved into like a more substantial machine. So potentially we will replace them eventually, but for now let's just use what we have. Let me get this straight again. So this one is the one with the one on the back. Let's see, so this one doesn't quite go in. You should not push too much. That's what I said as I pushed too much. I'm really confused why the parts don't fit well, because usually it's a calibrated machine. Okay, let me quickly try the other side. And for the other side, the wire goes to the bottom. Yeah, it's like ever so slightly too tight. Yeah, if I push now, I break it. Yeah, let's do the good old trick and like just give this like a very let's do this side first. Oh, but they are all the way in. Very confusing. That's definitely not correct. They need to be. So there's this little lip here, and that's where they collide. And we don't really want to take off like a lot of material, just to make them like slide a little bit smoother. No, yeah, that was it. Now it's in. Okay, so for some reason they like kind of like there's like this teeny tiny lip down here, and for some reason they didn't quite want to go behind it. Not sure if it's the fans or the printed part. I mean, it doesn't matter. Okay, then first you have to put in the hot end fan. And you need to be really careful with the cable here because it's really easy to like damage these cables when sliding in the fan. And then this one also gets routed along here. See if this one also fits in. Yeah, here we go. Perfect. Oh, the sticker. Let's see, can I get this out? Now it's in, okay. Well, the sticker kind of got like removed here a bit, but what gives? All the fans are installed. Let's already put 2 zip ties here, but have them like really loose so we can pass more cables through. It's just like for me to kind of like sort everything in a certain way, just like this. Cool. So, yeah. And let me actually put this back, because we don't need this to be off. That's for next time. That is for next time when we have the missing part. Cool, okay. That's the fans. Then the hot end. So here the cables are cut quite short. Don't remember why. This is also like a very cheap hot end, obviously. It's like a Ender 3 hot end, and like not even like an original Creality one, but a clone. See, so these route then on this side. Let's quickly put the motor on and the toolhead board. Then we can kind of like see where the cables need to go. So that's the toolhead board. Let's just kind of keep that all together. Very nice that it comes with the spacers. And here is the motor. So let me quickly grab 2 M3x8 screws. I can preliminarily mount the motor. I mean, there's nothing it's driving at the moment, but okay. Why does this not want to go in? Here we go. Okay. So that's the motor. Let's add the spacers. Just would measure. Let's give this a twist. Okay. Cool. And the toolhead board basically just comes on top of that. And then we have like our complete sandwich. We will have to take this apart again. When we complete the extruder next time, but for now, let's just put this together. Then we can already, well, actually, like the stepper cable should go. Let me quickly do this. I know it's just preliminary, but you know, Let's do it a little bit proper. So the stepper cable goes in the inside here, then it's long enough. And the stepper goes here. I'm not sure if that's the best way to route it, but that's how we do it now. These cables for the fans are definitely too long, so we need to shorten them. They go here, here, and here. I think we need to double check that. Let's quickly get the pin out for that. So we need the EBB36 pin out, and the Big Tree Tech documentation usually is much better than the mellow one. Okay, so we have interesting. So we have to wire both part cooling fans together. It only has one header for the part cooling fans. Well, excellent. Because I have no clue which one is not a part cooling fan. Let's get the hot end out again. Oof. I did not want to take this apart again. Let's quickly try. It also doesn't really help. But now we can kind of push from the bottom. Here we go. Ugh. Okay, we need to mark the part cooling fan. This is the part cooling fan. Let me just get like a marker and give that red wire. So these and these are part cooling. Then we can tell them apart, and I guess we have to crimp them together then. So let's put that back together. Okay. Then yeah, I guess they didn't tell exactly which fan is which, but I don't think it matters too much. So let's just double check that we have the two correct ones. This one has a black stripe, this one is not. Ha. This one has a black stripe. Okay. So these, let's just, we have to crimp them together to one connector. Let's just do it like not too short, not too long. Is it really like... It only has fan 1, fan 2. And then like this connector, the third one is TH0 and the one above is RGB. So they must go together. Okay. There will be experience. Let's give a little bit of working room here. And let's do the black one first. So back to our most favorite task of all. At the very least, these are not the small ones, but the normal sized ones. Yeah, let's see if we can kind of like twist them a bit, but I also want to have both of them then being like pressed together. So I just twisted them a tiny bit. You have to do the same on Dragon Burner and OXL toolheads. Yeah, I think like it's just like those toolhead boards are really meant to be used with like two fans. The LDO toolhead board I have on the V0 has 2 fan ports, but then it's also like specific for the V0. See? Hey. Oh, I'm trying to not lean forward too much. Okay. Here goes nothing. Oh, I didn't quite crimp forward enough. Forward enough. I mean, it looks good. Like both are properly crimped here. Like the isolation of both is grabbed, and like both are in the part, so it looks good to me. I would be happy with this one. Now the second one is of course a bit more difficult because now they're already like connected. Let's see. I need to get a tiny bit more cable. Oops. These are the situations like if you don't have the tools to crimp, you're a little bit screwed. Okay, here we go. There's also no standard which side is plus or minus, so you always have to pay attention to that. So I'll quickly get this out, but we were gonna use the black one from the parts we got from Toolhead board because black just looks nicer. Okay, maybe I recycle this later. Here we go. Oh, that was even the wrong one. Well, let's quickly. Two. Three. And 2 trash. Okay, so we have the V in is on the bottom. So V in is on the bottom. So this goes to the bottom. Okay, that's in. No. It broke. See if I can get this out. We have to recrimp the black one. It doesn't even want to come out anymore. Here we go. Okay. I mean, the other side looks okay. There is, if the brushless, it matters. I lost the context there, Steve. What do you mean with brushless, it matters? You mean which one is positive and which one negative? I was referring to the JST connector itself. Like for the fan, of course, it like the polarity matters because, like, I mean, yes, it doesn't spin, or it spins backwards. Both are not ideal ideal scenarios. Let's see. They're not well together. Let me also get like tiny bit more bare wire. Ugh. It's not super fun. Why don't you stay together, please? Sorry, I'll take out of frame. It's one of the crimps that's not super proper, but it looks like it's holding well, so let's use it. Okay, yeah, the red one is now like a tiny bit longer, of course, so it like bulges out, but should be fine. So if we now plug this in, double check, red is on the bottom. Cool, so this is okay. Not quite sure about the wire length, but yeah, that is now the cards we have been dealt with, or dealt. And then this one, let's just cut this. Roughly this length, and then let's quickly do a simple crimp. And then we are off to the hot end. Hey. This did not want to come apart, and now I ripped the... Okay. That's why you always like cut it a bit longer. Here we go. So okay. Should be a walk in the park now. Should be, but it's not. Let's try this again. Okay, that's one. Almost there. Kind of should have expected a lot of crimping this stream, but yep. My crimping patience slowly comes to its end. Okay. I assume it's the same, yeah. So the, oh wait, I don't want white. White goes back. I want black. And for black, we have red wire on the bottom. And the ground wire on top. Perfect. Okay. Then hot end. So we need to take care of the thermistor and of for the actual hot end wire, hot end power. So, oh yeah, we should also maybe already, like, because there will be like a clicky probe here, let's also connect these already. But let's first do the hot end. Let's see, so we definitely need to solder these wires. I don't have solder stuff here yet. I need to quickly grab that. Let me also see, I think I still have the exact red wire here. So we can just extend it with the exact same wire. I do have heat shrink. Which you can use. I even have red one. Then we can heat shrink the red wire with red heat shrink. They're pre-cut, they're the same length, that's perfect. I'm just putting this already on there because I know myself very well. I will forget later. So let's put this here. And for the white cable, I don't have white heat shrink that small. So I have this black one here we can use. There's this like clear thingy here. I don't want to peel it off right now, but that makes it basically impossible to have the heat shrink on this side. So we need to have it on the other side of the cable then. Okay, let me quickly get my soldering stuff. I have my soldering iron, but I don't have tin yet. So I need to quickly grab that. Well, we can already plug in the soldering iron, then it's heated up when we need it. Perfect. Okay, I'm back in a second. Okay, that's like watching these projects, but the cost of a BOM of this compared to buying a V0.2 from Cyber kind of puts me off building this type of printer. I learned the hard how to weigh the switch wire. Yeah, that's the thing, right? Like, if you have the commercial kits, you cannot match the price with like smaller custom machines. What is a Cyber V0 running for at the moment? I think like 350, 400, something it is. Like, yeah, this will be close. 300 euros for sure. I think maybe a bit cheaper, but then like you always have to consider like, you know, like the things you forget and you have to rebuy. But it's always like if you buy pre-made kit, I think it will almost always be cheaper. Oh, I forgot the wire. Oh, okay, let me quickly grab the wire. Sorry, right back. $349, yeah. There's no discussion. Like for $349, the kit is cheaper, of course. I mean, not cheaper necessarily. I'm pretty sure you can get this like a bit cheaper than $349. But not sure if it's worth it, to be honest. This is more about the fun. I'm also not sure if like anyone should consider building that themselves, to be honest. For me, it's fun to build it, to learn. I'm very professional now. I have like a fume extractor. Maybe turning on soldering irons is helpful. Let's quickly wait until that gets up to speed. Let's also quickly collect all the connectors I kind of like dumped here. But yeah, like depends, right? Like the Seabor, it doesn't have like a lot of like special stuff. It's a very basic kit, if I remember correctly. I mean, this one now most likely is price-wise over it because like I have stuff like a canvas Toolhead board, where yeah, that just adds to the cost, of course. But to be honest, like the electronics are quite cheap now for this machine. The electronics are quite cheap because the main board is like only 25 and this canvas Toolhead board is also like only 16. So like although it's a little bit fancy with canvas, like it's not super expensive. Sure, this is like a good connection because it will have like a fair amount of power flowing through it. Okay, that's part one, and I of course don't have a lighter. That's the annoying part because like I don't like this is like my dining table. I always have to like store stuff in other places. And then like for the stream I always have to like plan out what I need, what I don't need. And I always forget stuff. It also works quite well now with the soldering iron. Despite that I smeared solder all over this one. Cool. Okay, that's the extension for this. We can then, let me just like generously cut this. Don't have this like roll of wire flying around. And I think we can kind of like route it on the bottom along and put it something like here. Okay, let's extend the short one. Let me see what wire I can use for that. We can use the silicon wire, of course. You know what? Let's just use the wire we cut from the end stop. Okay. Let's actually get this out of the toolhead for now. Kind of like dangle this a bit. Let's first turn this up. Land it. There's nothing on the other side, so we can like put the heat shrink over later. Okay, that's one. Then we need a second piece. Let's just use the whole thing, I guess. Oh, that's just first. That's not good. It should be like more parallel. Yep. Okay. Nope, that's not a good connection. I mean, sometimes it always looks good from one side, but then like when you rotate it, like it looks crappy. Oh, come on. Okay, this looks okay. Then let's heat shrink this. Hope the small heat shrink fits over that, and I don't think it does. I think we need a bigger one there. We'll see total cost when it's built and ready to release. Yeah, I mean, part-wise, it should be quite final, right? I didn't tally it up. But part-wise, it should be... I think we have everything together now. I wouldn't know what we are missing from parts. It's more like that, like the combination maybe will change, like how the parts fit together. But generally, I think it's relatively cheap because it uses like a lot of like similar parts all over the place. Like you don't need like a lot of different parts. I try to reuse the same components in different spots of the printer. There's like a weird blob of solar on the side. Okay. Let's see. This wire is relatively thick for like a thermistor, but yeah. Okay. Everything is on. Proud of myself if I don't burn myself here. Seems like I manage. Cool. Everything is extended. Okay, that's enough soldering for now. I mean, I can actually like tally it up. I mean, if you, let's not count filament because like the Seaboard kit also doesn't count filament, right? So you need a hot end. Let's say like 20 euros for a hot end is fair. You need fans, let's say 10, so 30. You need toolhead board is 15, so it's like 45. Motor is 15, so it's 60. Electronics, we said main board is like 20, so it's like 80. You need the gates belt, that's like 10, so 90. You need the bed, which is 30, so 120. You need 4 steppers, that's like, I don't know, 30 euros, so 150. You need the smooth rods, that's 10, so 140, I think, if I didn't lose track, 140. You need the bearings, that's like 5, so 145. You need 145, or did I forget now? You need like the, let's say like hardware in general, like screws, whatnot. Let's say like 20, so it's like 165. You need like the hardware store parts, so it's like 175. They're not expensive, 175. You need like miscellaneous stuff like springs, whatnot. Let's just add another 10, 185. You need a power supply, that's like 20, so it's like 205. What else do you need? I feel like I forgot something. I think everything was now counted. Like material, like you need of course like filament and stuff. You need cables. Let's add like another 15 for cables, so it's like 220. Oh, the bearing stacks, that's like, I would say 15, roughly. So it's like 235. Let's say 20 with the pulleys, so it's like 240 with the pulleys. Yeah, the bearing stacks were the last expensive part. I would say like 250 if you buy it cheap. If you buy it cheap. Yeah, no, but like I don't think it's like super expensive because like, yeah, you don't need linear rails, which are usually quite expensive. You don't need lead screws or something. You can have the same for, like you can buy one motor and use it in all 4 spots. So yeah, that I think makes it quite cheap, because like you can reuse all the things. Like you don't need like a million different screws, right? There are some special screws you need like a handful. Like for the bed, you need like the countersunk screws, relatively long. There are 2-3 special screws you need for the tool head. But in general, there's also like, you know, like you don't buy like 2 screws. Usually you buy like 50. It's like the question, do you like calculate an entire cost of all the screws for this project, or like only the partial cost? Because like if you get a kit from Zibo, right, they give you the matching amount of screws. But if you, for example, like self-store something like this, you will buy large packs of screws, because like that's kind of like what's available. And also like price-wise doesn't make sense really to like buy small quantities. Yeah, I think like it's best to route this here on the bottom, but I'm not sure if that actually works, because there's this pin. Let's quickly check that out on the printer. I think we're done with soldering, so let me get this stuff out of the way. Yep. I'm kind of like running out of space today. Like, not enough desk space. Let's get rid of the crimping pliers, so we don't need those again. Oh, we will need them again. All goes to the trash. Okay, here we go. By the way, I'm not sure if this was the best choice, like the silicone cable for the umbilical. Let's see about that. Let's go like that. Okay. Let's see how we can route the cables. So there's this like pin here, and I want to route the cables like underneath here. And I'm just interested to see if that gets in the way, and the answer is a very clear yes. So we cannot run it under. So I mean, we can run it on top, but it also is a little bit awkward. So I guess it's just like some freestyle back here. Then I guess like lengthwise. Oh, sorry. Something like this. Lengthwise, kind of like put in here. Unisolate quite a bit there. And get 2 ferrules. That was clearly not enough. Okay, yeah, that is not good. Let me quickly check. I think there were like some included. No, they didn't include ferrules. Okay, now of course cut it like not super short. So what we can do is we can unisolate a little bit more. There we have like quite a bit. And then you can just fold it on top of each other. And then hopefully, let's just use the pliers to like compress it, and then we should be able to feed it into the ferrule. No, that's not gonna. I'm a bit confused why, because these are 0.5 square millimeter. They should fit this cable quite well. Let me try to extend this again. Another shot. Yeah, now it's fine. Okay. Huh, weird. Okay, let's nevertheless do that here as well. Let's get a bit more. Maybe it's just like it wasn't enough cable in the ferrule. Okay. And then for the teeny tiny terminal here, like these ferrules are way too long, so I'll just shorten them to half. And need a smaller bit. That's a tiny one. And then it's always hot and doesn't have polarity. Oh yeah, we have to like squish them a bit, I think. Let's see that we kind of, they barely fit in there. Huh? Okay, tuck test pass. Not sure if it would have been better to just have bare wire here. Such a minuscule terminal. Okay, maybe without ferro connectors would have been better. As it's just so small that like the ferro connector just doesn't fit in, and it's already like, here we go. Okay, a bit more squishing solved the problem. Whew, okay. Then maybe later we can like use one zip tie here to kind of bundle these. But there is more to come. Oh. Oh, that's annoying. I didn't push this one fully through. Now this cable is a lot longer. Let's swap the two sides. So the longer cable at least goes to the rear terminal. But I'm not gonna oh. Okay. Okay, let's remove the ferrules. Because now the ferrule is stuck in the terminal. And I don't feel like they have like tons of grip, so. But at least not a longer cable. It's the one with the bad wire, so. Oops. And we don't use ferrules here. Let's twist it a bit, but no ferrule. I don't feel like ferrule is a good choice here. Okay. Perfect. Now they're all equal-ish length. Okay. This side we can actually already like zip tie because there's nothing else gonna go through here. Unless at some point we add LEDs, but that is. I have the parts for LEDs, but not today. Okay. Then let's get rid of the ferrule stuff. That did not work out at all. And quickly check the documentation. So technically, like, we now have all the things here that we need, right? We have the stepper driver. We have the fans all in place. We have the hot end. Thermistor would have been kind of important. Let's do it like this. And crimp a thermistor. It's definitely too long. More crimping equals more fun. And then we can check for the probe. Oh, see, Steve, I forgot the probe. Let's add like another 10 euro for the probe, so it's like 270. Because for the probe you need one servo. You need one servo. Oops. Let's get a black JST housing from here. They don't have polarity, so we can just put them in wherever. Here we go. Perfect. Cool. Then probe. So we use slide swipe. Which looks like this. It's made for the V0, but we will adopt the dock. And this is how, yeah, this is how it will operate. And then basically on the bottom here, there's two magnet holes. I don't have the magnets here, so we need to quickly grab the magnets. But yeah, that's basically where the probe then attaches. And yeah, it's very cheap because all you need is like the servo, micro switch, 4 magnets, and that's pretty much it. Exactly, that's the entire thing. Okay, so let's quickly go through. We're not interested in doing this part yet. I'm only interested in doing the Toolhead part. Exactly, so they use JST stuff. It's quite interesting, like they... What was it now? Here. I assume that this cable is then supposed to go to the top, so it should be... I assume. Right? I mean, yes, this needs to be... Yeah, okay, this needs to be longer. Then the question is, what type of cable do we want to use here? Doesn't need to be like super thick wire. I mean, we could use the same black that we also used for the other. It's a bit bendable. Let's see if that's... Might be a bit too thick, to be honest. Yeah, it doesn't fit in this little... So there are two openings here. I mean, it's also kind of for the LED, but they kind of use it as well. So it's here for... This one comes out here. And this one, I think, slides all the way back to this one. And this cable is too thick. So this is out. Let me see what I have like flying around here. I do have like very thin cable here, which is 24. That's not it. 15 up a bit. Let's use this one. This is the same that I used on the V0 for the Toolhead light. That's 30 gauge? 30. Just grab like 2 times this. Make one a bit longer because it needs to be to the front. And let me put a knot here in again, because otherwise that kind of super messy. Okay. Then let's put the long one in already. Just have to like maneuver that through here. Not sure if I do anything. Okay, this is not easy to push through. Try again. Oh, now went through. Whew. Okay, let's leave this here. This should be long enough to reach. Yeah, that's okay. Then let's crimp the JST later. So what they do is they unisolate a bit of length. Should have done it after putting it in, but hey. And then you just need to make sure that the magnet contacts this wire, basically when you now put in the magnet. So let's fold it a bit over. I'm just trying to like put this in the hole, but also like a little bit on the side that the magnet for sure contacts it properly. Okay, let me quickly grab the magnets. I'm back in a second. Send a 2mm drill bit down. I don't have a drill bit that is 2mm, Steve. I think 3 is the smallest I have actually. Okay, this looks like it's the right magnet size. Double check. Let me see, what do they say here? I put in the wrong magnet. Magnet. M3. Screws, tools. 6 diameter and 3. 6, 3. Okay, it's these. So this one is, looks like the same. Yeah. Okay. The polarity shouldn't matter for these now. And then what they do is, I assume they just put glue in there. Put some super glue on the rims. Yeah. But just for good measure, let's use a bit more wire because I'm a bit concerned because it's not quite thin. I just want it to be making good contact. Okay, super glue. I love super glue. What could go wrong? So let's try to put tiny bit around. Just put it like on the edges and press the magnet in. Well, that was quite okay. Where's the second magnet now? Ah, here. Attached to the motor. Let's. Whew. That was close. Let's repeat that. Let me close this before like bad things happen. Just for fun, let's make sure we have the same polarity. Uh-oh. Oops. This doesn't go in. I think because like the overhang here is a little bit bad. Just remove like a bit of material. Now we have like random. Okay. I add a tiny bit more super glue. And let's. Oh no, not the classic. Ah. Super glue and magnet. Classic. How can I push this in? The hind one went in so well. I'm also a bit concerned about destroying the cable here, but we have more of the cable. Okay, let's remove a bit more material. Oh, also here, this cable I kind of pulled out a bit. Ui. Okay, like another bit of material shaved off. I am concerned if this will work. Try to. No, this does not go in. Yeah, and this cable completely goes out, so this is not really. Same for this one. You can also pull. Yeah. Okay, let's try this again. I pushed the magnet out from the bottom, just like here with the screwdriver. So that went quite well. Okay, let's first make sure that the magnet goes in before we do anything wire related. And super glue related. That's another thing. I don't want super glue all over the place. Okay, now it seems to go in. Yeah. So now the magnet goes in. Now does the magnet go out again? That's the question. Yes, it also goes out again. Cool. Okay, now that this is settled, I'm not sure if we can recycle these wires. Let's try. I do not think so. Okay. Then I'm not sure if they're long enough still. Let me quickly see if I push this in. I'm not sure how I got this now in like once. Yeah, here we go. Okay. Okay, here we go. Let's first check that this is indeed still long enough. Yes, we have enough range. Then let's unisolate quite a bit. like make a little loop. The loop and it was chaos. Okay, let's do the following. So we put this in here. We put the magnet on top with a bit of glue. And then there's like the cable's visible here for a bit. Let's also dab a bit of super glue there to prevent the cable from being pulled out. And we do that after we verify that we indeed have connectivity. Putting an all-nighter? No, definitely not. Like this is the... I'm gonna finish this up. And then it's the end. Usually I stop at like my time 11:30, which we are now a little bit over. Okay. Let me see that I push this in. Okay, that magnet is in. There's now bits of super glue on the surface from the previous attempt, but we can just use like alcohol to like remove that. Do I have? I don't have. Okay, I'll clean this up later. But for now, the important part is: do we get connectivity? Let me unisolate a bit on the end. So if I put this here and I put this on the magnet, yes, it's beeping. So we have continuity between the two. So that's good. Then let's do the following. So I'll dab like a bit of super glue here in the side before I put in the other cable, because I want the other cable to be kind of like on top, but then basically that prevents it from being like pulled out again. Cool. Then this one we can definitely recycle because how long does super glue need to dry? But if there's super glue on there, I don't want that anymore. So let's twist it up. Ah, wait. Let's first put it in and then twist it up. Here we go. Okay. This goes in here basically. Let's add a bit of super glue on the side for the magnet to stay in. Pop the magnet on top that we have the same polarity. And then this one I remember was very easy to settle in. Cool, okay. Let's also do the continuity check for the front one. I think this will work fine. Yeah. Also, we have continuity there. So these two magnets now are basically our clicky probe. Let me see. So I'm bit concerned like pulling out this cable, but I also don't want to add super glue there because I kind of want to have the option to later add LEDs. So let me kind of like glue these cable here a bit together. And then in case we need to get them out at any point, like we can use alcohol to okay, I don't think this helps too much, but I also don't expect like a lot of force. Cool. Okay, then let's do one last crimp. With the tiniest wire possible. I remember these were like really annoying to crimp. Let's go back to the documentation here. So we have basically for the end stop pin, I think is what we should use. I assume it doesn't matter. I assume we can use 5 volt and PV6. But yeah, let's just crimp the JST. It's a small one. Wait. Let's do 2 more crimps and then we're done with crimping. Yeah, so it's a little bit glued there. Won't hold much, but better than nothing. Oh, I lost my crimp, but I also don't have crimping pliers, which I definitely need. Oh, where is it now? Here. Okay. That did not work. I think I have to crimp these on the smallest preset. Because these cables are so incredibly tiny. No, I damaged the cable there a tiny bit, but it should be fine. But yeah, small preset is definitely required. Quickly. One from here. Oop. Maybe it's even better to solder these mini cables to a little bit thicker cables. And then crimp these. Yeah, this one is good. Okay, perfect. There is a black housing for that. So we can take one is the outermost. One is the outermost, check, and then one free, and then check. Oh no, we forgot the that needs to go through the zip tie. Okay. Sorry, zip tie. Oh, where's my bag of zip ties? Let's get one more zip tie going. That is one zip tie. Let's use one more a little bit further up here, just to get this all sorted. Check. Not sure if we need like something for these two. I don't think so. I mean, for good measure. Tips. Here we go. This is our tool head. Mostly, like, there's no gears yet, but besides that, it's a tool head. Has all the wires one would expect. Now looking at this, maybe it would have been even better to route this here on this side and like zip tie it with this one. Yeah, next time we can optimize that a bit. No, that's okay. Let's quickly do this for my personal fun. Let's get this out of there. I also quickly might spray paint these black during the week. Don't really like the gold. Oh no! Aha! I missed the. Make sure we have all the wires of the motor. I do. Okay. Here we go. Okay. I call this tidy. Let's quickly throw it on the printer. And then I would call it quits for today. I think we made a lot of progress. I mean, I don't want to cut the belt yet in case we need to change some minor detail of the belt run. I want to have a little bit of extra. I'm kind of running out of space to put that. Yeah, and then there is one more screw from the back, but I'm not quite sure what type of screw we need there, because I changed that. I made it a bit longer, so that's something to figure out what we need there. I think it's a M3 by 16. This one should work. So let me. It was a bit difficult, and we will totally have to remove this next time again. It's just like now I remember that there's a screw, and I see myself forgetting that. Okay, I don't get it, but the screw is there as a reminder for next time. You will have places to tie them to a cable management for the canvas cable at the top. Oh, you mean the motor wires? I think this is like a nicer solution because there's nothing over the top. Yeah, and then next time we still need to do. I didn't do that yet, but this fun cable. I need to see what we do with this. So this needs to be tied down somewhere on the back here. But to be honest, like this is not the worst cable for this. Just need to figure out the length, but this works quite well, to be honest. There's no tension, it's like very floppy, but that's okay. One thing we can consider is whether we like do it like this, and then like cable tie it fixed that like there's no tension on the connector. Or if we find like another spot, maybe we can cable tie it to the side here, to the stud. That there's no tension on the connector. That's like a little like strain relief, and then like this can like just like flop around, like doesn't really matter. I actually like this. Like maybe we can just cable tie it to that little stud there. Just that like there's no like movement on the connector directly. Cool. Okay. Perfect. I would cut off here. A bit longer than I expected. I'm actually quite tired now. So things I will do for next stream are we still have like the problem is like we have a bug in these parts here on the back side, right? Like the belts are not properly aligned. But I also know like I will redesign them and then we have to reprint them anyways. I think it's fine. The belts are not perfectly aligned there, but yeah. I don't expect like perfect prints in the beginning anyways. It's just that we get something printing. And yeah, so for this situation here with the bare connectors, I'll come up with a solution. Just like temporary fix that these are not open, although like should be fine, right? Yeah, and then I ordered the part for the power connector, and that's pretty much it. And the next time we will just, I will also flash the board. I will flash the board most likely. And the next time we can configure the Toolhead board, we can install the extruder, and it should print. It should print. So I'm really excited. With that being said, thank you everyone for tuning in, and see you next week then. Have a good weekend. Bye.